something that really is remarkable that happened in the last few weeks. There was papers that were published. They were able to remeasure the radius of the proton more precisely using standard techniques, that is, using electrons instead of muons. One remaining criticism on my prediction of the radius of the proton, which is critical, was that, this new radius of the proton, which is 4% smaller than is predicted by QED, by the standard model, is maybe wrong, although it was verified twice, 2010 and 2013, and it produced what's called a proton puzzle, the proton radius puzzle. There was a lot of literature saying, well, maybe because they use muons, which are heavy electrons, they flexed the proton radius. The elasticity of the proton radius kind of pushed in when the electron was scattered off it. Mm-hmm. And that's why we got a smaller radius and all this stuff, trying to avoid the problem, because if the radius is 4% smaller, all of a sudden all of the standard model QED just goes out the window, because it's highly reliant on that radius being specifically what it used to be. And so in the last few weeks, published papers were reporting on experiments that were done where they used normal electrons. They used the earlier techniques, but more precisely, and they got the same radius. They got the radius that they got from the muonic experiment, the radius that my equations predict. So that means that, and it's funny because the standard, like there's actually articles in the press out there saying, oh, physics is not broken after all. We confirmed that the radius was the muonic radius. Well, actually, that's wrong. And it's like there's physicists out there that are a little confused, because the fact that we predict that that they confirm this radius having been 4% smaller totally breaks physics. I mean, the standard model of physics. The universe is doing just fine. But the standard model of physics broken. QED is in big trouble because the Reinberg constant, which is very precisely measured as well, and the radius of the proton now being 4% smaller, precisely measured there, doesn't work inside the QED theory. That is, the QED theory actually used the proton radius as a variable to adjust to the Reinberg constant, and it gave the radius that they thought it was. Now, if it's 4% smaller, all of a sudden the Reinberg constant goes up in smoke, which was thought to be, the most precise prediction of any theory, on the planet ever. Well, all of a sudden it's wrong by a long shot, because it was precise to like some 12 or 10 digit accuracy. But if it's 4% wrong, now it's not precise at all. And so the only theory that actually gives the correct Reinberg constant and radius of the proton and its mass and the mass of the universe, of course, and the mass, without the need for dark matter and dark energy and the mass of all the electrons. The only theory that actually does the job is the holographic mass solution. And that's why it gives the correct prediction for the radius of the proton. So that's a really good news.